Hi guys! So we are going to start chapter 3 study guide. Super exciting stuff over here. So we're just going to get into it. So number 1 says determine if the graph is even, odd, or neither. So remember, to do that, we are always plugging in f of negative x. So if f of negative x equals f of x, then it's even. If f of negative x equals negative f of x, then it's odd. Okay, so we're going to start there. We're going to start with A. So I always like to kind of start it with looking at what would negative f of x be. So if we were to do that, negative f of x. Now remember, this is a fraction. So when we multiply a fraction by negative 1, we can either multiply the top by negative 1. Oops, I didn't multiply the top. So sorry. Whew. There we go. White out. Okay, so it'd be minus x squared over 1 plus x to the 4th. Or it can be the bottom too. So 4 plus x squared, and then everything in the bottom would be negative. So it could be one or the other, and that's really like where fractions are tricky, because it could be odd if it was multiplied on the top or multiplied on the bottom. So let's plug in f of negative x. So that would be 4 plus negative x squared all over 1 plus negative x to the 4th. Now, negative x times negative x gets me a positive x. And then negative x times itself 4 times gets me x to the 4th, positive as well. So the negatives actually go away, and what ends up happening is this is the same as the original. So f of negative x equals f of x, so it's even. Okay, so that's the first one. With B, so same deal. If you want, you can always write out what negative f of x is. So that's just multiplying everything through by negative 1. So negative 1 minus x squared. So you don't have to write that out. It's just nice to compare it at the end if it's the same as the original or if it's the same as the function multiplied by negative 1. So when we plug in negative x, that would be 1 plus negative x plus negative x squared. So what ends up happening is this negative x stays there, and this negative x squared goes away. So if you look, it's not the same as this one because of this minus, and it's not the same as this one because the only thing that really changed was this minus. So what this one is actually neither. Okay, and then for C, start the same. Now again, you can write out negative g of x. So again, it can either be on top, so negative 1 minus x squared over x cubed, or it can be on bottom, so 1 plus x squared over negative x cubed. And so when we plug in negative x, we plug it in to our equation, so negative x squared all over negative x cubed. So the negative x squared here simplifies to be positive, and then negative x cubed, the negative comes out, and it's negative x cubed. So what ends up is this one here is the same as that one. And so when g of negative x is the same as negative g of x, it's odd. And that does it for number 1. So remember, with even, odd, or neither, your first step, or like the big step there, is always just plugging in negative x into your function to determine if it's even or odd. That's all you have to do. Okay, so let's move on to 2. It says find the domain of each function. So before I even do anything. I'm going to look at A, B, and C and classify these. So A has a variable in the denominator and no square roots. So because of the variable in the denominator, that tells me that this is a rational function. Okay? And then for B, now it's trying to trick you into thinking it's a rational function, but it's not. The reason it's not a rational function is because there's not a variable in the denominator. There's only 3. So this is actually a polynomial. And then this last one, well, it has a variable in the denominator and it's also under a square root, so it's both a rational and a radical. Okay, so with that, we're going to start with the rational with A. So with rational equations or rational functions, what we really care about is the denominator. And why we care about that is because in a fraction, the denominator can't be equal to 0. And remember, with the domain, what we're always thinking about is what values work for this function. And probably more easy is to think is what values don't work for this function. And so in this case, it's any value, any x value that makes the denominator 0. So that's why we set the denominator, 2x squared plus x minus 10, equal to 0, and then we solve for x. Now, you see an x squared, that should always be an indicator. And x squared means we have to either solve for x by factoring or using the quadratic formula. Now, I'm going to try and factor. So remember, on top is 2 times negative 10, so negative 20, and on bottom is my b, which is 1. And so I'm thinking what 2 numbers multiply together to get me negative 20 and add to get me 1. And so that's going to be 5 and negative 4. So that's where I can split my middle term. Remember, 2x squared stays the same. Now I'm going to put minus 4x with that because it goes better with 2x. And then 5x with the minus 10. So see how negative 4x plus 5x is still x. That's why we split the middle term. And now that we have 4 terms, we can factor by grouping. So I'm going to move up here because I'm kind of running out of room. So I can factor out a 2x from there, and I'd be left with x minus 2. And then I can factor out a 5, and I'm again left with x minus 2. So now that these are the same, I can use this, 2x plus 5, times x minus 2, and now I have my 2 factors. Once I have my 2 factors, I can set them both equal to 0. Oops, minus 2 equals 0. And then solve for x. So we're going to subtract 5 and divide by 2. So that would get me negative 5 halves. And then add 2 and we get positive 2. Now remember, these are the excluded values because we don't want the denominator to be equal to 10. So x can't be equal to negative 5 halves and it can't be equal to 2. And so when we write that in interval notation, it kind of is the long one. So it's where we say, okay, it can be basically negative infinity to negative 5 halves. Now we use parentheses to say, okay, so this is kind of the end point, but it can't actually be that number. And then union, start again, negative 5 halves, still in parentheses because it can't be equal to that number. And then 2, and then union 2 to infinity. So it's essentially saying, really, it's every single number except negative 5 halves and 2. Okay, so then onto the polynomial. Polynomials, really easy. Polynomials always have the same domain. It's all real numbers because I can plug in any number here and I'm going to get an outcome. I can plug in a negative, I can plug in a 0. Even if I got 0 on top here, 0 divided by 3 is still 0. So it works, it's a number. Okay, so then part C, because it's a rational and a radical. So rational, remember, that means we set it greater than or equal to 0. No, I switched those. Rational means it can't be equal to 0. I don't know why I'm saying can't weird. It's like I'm from I don't know. And then radical means it has to be greater than or equal to 0. So if we combine those, we just get greater than 0. It can't be equal to, and it has to be greater than or equal to, so we just do greater than. So we're going to set the 2x plus 10 greater than 0 and solve for x. So subtract 10, divide by 2, and we get x has to be greater than negative 5. So if we plug that in, all we do now, not plug it in, if we write in interval notation, because it's not or equal to, it's parentheses, negative 5 to infinity. So if it was the or equal to, so if it was just a radical, it would be a bracket. So remember, bracket is equal to, parentheses is when it's not equal to. Okay, that does it for 1 and 2. I'm going to start 3 on the next one.